Hello, students. Good afternoon. So good afternoon, all of you. Okay, Karinagar students are here. Then JNVP class 11. Okay, great. So it's almost time. Okay, hi JNV Karimnagar students. Hey, I'm good. I'm good. You are from which state? Karimnagar means from Andhra or Telangana? Yeah, Telangana. Okay. Great. Then JNVP from which state? From Andhra, Kerala, or Telangana? You can tell me in the chat box. So first of all, I'm launching the technical check for you. So technical formalities. If everything is fine, then positive sign. Okay. Okay, perfect. Yes. So everything is properly visible. Internet connection is stable. It's good. Great. Oh, 2 out of 2. Okay, I'm ending the poll. That's enough. More than enough. Then JNVP students, class 11. You have to tell me from which. Okay, Maharashtra. Okay, JNVP means full name. What is the full name of the JNV? My guess was wrong. Okay, Pune. Okay, JNV Pune. Okay, great. Okay, there are different JNVP. Palakkad is there, JNV Prakasham is there. So different JNV. Okay, great. So we will start it. So most probably this will be our last organic chemistry GOC chapter class. So organic chemistry, some basic principles and techniques. Okay, so technically everything is perfect. So let us start. So before introducing some new topics, we have to recall what we have learned in the last class. In the last class, we were studying about one thing, what was that? Purification. We have studied that. Then qualitative analysis of organic compounds. Qualitative analysis. What is that? In an organic compound, which are the elements present? Whether carbon is present, hydrogen is present, oxygen is present, sulfur is present. So we have done so many tests. I think Karimnagar students can answer this one. So question, this is also a previous year question. Okay, in sodium fusion test of organic compounds, the nitrogen of the organic compound is converted into JNV Pune students and JNV Warangal. Okay, you can guess. If you don't know the answer, at least you can guess the answer. So nitrogen, sodium fusion test. I think you were not present in the last class. It's fine. Okay, I will explain it once more. We will revise the topics. Okay, any answer? So do you know the answer? It is based on last class. Last class, what we have learned. In sodium fusion test of organic compounds, the nitrogen of the organic compound. Yeah, JNV Karimnagar students, that is correct. So it is converted into what? Sodium cyanide, that is NaCN. So NaCN, okay, sodium cyanide. So nitrogen is converted into sodium cyanide. This is a previous year question. So I will repeat the concept once more. So what we have studied in the last class. So we are studying about qualitative analysis of organic compounds. What is that? We want to detect the presence of these elements. So we have an organic compound. In that organic compound, which are the elements present? So we have to detect that. That is known as qualitative analysis. No need to calculate the amount of element or percentage of element present. There is quantitative analysis. In quantitative analysis, we will study about how to calculate the percentage of the element present in the organic compound. So in qualitative analysis, we can detect whether carbon is present, hydrogen, oxygen, nitrogen, sulfur, halogen. X means halogen, then P means phosphorus. Different elements we can detect. There are different tests for each element. So we have to study that. So first test that we have studied in the last class, that is Lassaigne test. So what is happening here? I'm taking a fusion tube, small tube, smaller than your test tube. In that, I'm putting a sodium metal, highly reactive. So I'm boiling that, okay? It is highly reactive. Then after that, to that fusion tube, I'm adding some organic compound. In that organic compound, maybe carbon is present, maybe halogen is present, maybe nitrogen, maybe phosphorus. I don't know what is present. Then we will put this mixture into a china dish, then crush into a small pieces. Then sodium fusion extract is ready. So sodium fusion extract is ready. So why we are treating the organic compound with sodium metal? Why? So these elements in our organic compound, they are in covalent form. So we are converting them into ionic form. Why ionic form? It is more reactive. So reactions, it will be more easy. Suppose in our organic compound, there is carbon. There is nitrogen also present. Then what is forming? Sodium, carbon, nitrogen. So sodium cyanide is formed here. Sodium cyanide. So that was a previous year question. Then sodium and sulfur is present. Then Na2S will be formed. Sodium sulfide. Sodium and halogen is present. Then NaX is formed. X means chlorine, bromine, iodine, etc. Okay. Then after that, we have to do the test for that. So in the last class, we have studied the test for carbon, nitrogen, then sulfur also. In the case of carbon and hydrogen, we use a technique called Lebig's method. So that method is known as Lebig's method. Okay. In the case of nitrogen, we have studied about Prussian blue. Prussian blue, that is a color, blue color. So what is a complex form? So that we have discussed in the last class. In the case of sodium, there is lead acetate. In the case of sulfur, there is lead acetate test as well as sodium nitroprusside test. So we have studied these things in the last class. In the case of lead acetate test, if sulfur is present, PBS is formed. So that is black precipitate. In the case of sodium nitroprusside, a violet complex is formed. If color is violet, okay, we can say sulfur is present. Then sodium plus halogen, NaX is formed. So from there onwards, we will start. Okay, so in the today's class, first we will study about test for halogen. How we can detect the presence of halogen, whether halogen is present or not. So I have sodium fusion extract. That means sodium and halogen. That is X. So NaX is present. So we have NaX. We have NaX here. Okay. Then after that, we are adding some nitric acid, then some silver nitrate. So nitric acid, you know, that is HNO3. So here we have HNO3. Here we have AgNO3. AgNO3. Okay. Then what is the reaction happening? So here we have NaX. So Na plus and X minus. So I'm taking this X minus. Then from here, I have Ag plus. So Ag plus and X minus. I'm getting AgX. What is X? That is halogen. So I will get AgCl or AgBr or AgI. Generally, fluorine we are not taking. Okay, I will explain that. So AgCl, AgBr, AgI can be formed. So we have to identify whether chlorine is present, bromine is present, or iodine. How to do that? So we have to check that whether it is AgCl form or AgBr form or AgI form. So how to check that one? So that is Lassaigne test. Lassaigne test or sodium fusion extract we are using in this test, or Lassaigne extract we can call it as. If chlorine is present, then what is formed here? We have AgCl. AgCl is formed. So that is a precipitate. So what is the color of that precipitate? That is white. If white precipitate is formed, that means AgCl. If AgCl is formed, we can say chlorine is present in our organic compound. One more test for that. We are taking ammonium hydroxide. Add some AgCl. If AgCl or our silver chloride, that is soluble. Okay, our silver chloride is soluble in ammonium hydroxide. So we can say the 11% is chlorine. Second one, if it is AgBr form, AgBr is formed. So AgBr, that is a precipitate. What is the color? Pale yellow. If pale yellow color is formed, that is silver bromide. That means bromine is the 11%. Then it is sparingly soluble in ammonium hydroxide. So confirmation done. Then silver iodide. Third one, I have silver iodide. AgI. So that is silver iodide. What is the color of that precipitate? That is yellow. AgF is more soluble. That is why we are not taking fluorine. So this color is very important. AgCl, white precipitate. AgBr, pale yellow precipitate. AgI, yellow precipitate. Then in ammonium hydroxide, soluble, sparingly soluble, insoluble. So we found which are the elements, which are the halogens present: chlorine, bromine, or iodine. Is that clear to you? Based on the color of the precipitate and using ammonium hydroxide, we can test this one. Is that clear? Test for halogen, test for halogen. So pale yellow. Then last one, yellow color. These are the different tests for halogen. So sodium fusion extract. So AgX is formed. So chlorine, bromine, iodine. So I hope it is clear to you. Test for halogen, it is clear to you. Yes or no? In the chat box, JNV Pune students. JNV Akola from Maharashtra, right? Then JNV Warangal. JNV Srikakulam students are back. Great, great. So that is great. So JNV Srikakulam students always they are ready to give the answers. I hope this is clear to you. The test for halogen. So this is a test for our halogen. So next one, test for phosphorus. So what is happening in the case of phosphorus? So what are the reactions happening? We have to study that. First, I'm taking an organic compound. Then I'm treating that organic compound with sodium peroxide. So what is sodium peroxide? Na2O2. Na2O2. You know hydrogen peroxide, that is H2O2. So here Na2O2, that is sodium peroxide. It is acting like a oxidizing agent. So phosphorus is present, then Na2O2, then some heat. So triangle means heat. Then what is formed? Na3P4, that is known as sodium phosphate. So this is the first step for the test for phosphorus. So we have sodium phosphate. So what we have to do next? So I'm taking sodium phosphate. Then I'm treating that with our nitric acid, So Na3P4 plus HNO3. I'm getting H3PO4 plus nano3. Nano. So Tata car, nano. So Na3P4 plus HNO3, I'm getting H3PO4 plus NaNO3. Then what is the next step? So here I have ammonium molybdate. So I have H3PO4. So I'm taking my H3PO4. So where is my H3PO4? Yeah, here H3PO4 is present. I'm treating H3PO4 with ammonium molybdate. So molybdenum, that is MO, that is our molybdenum. So this is our molybdenum, right? So ammonium molybdate, then HNO3. Then what is formed here? Ammonium phosphomolybdate. That is formed. So how to remember this ammonium phosphomolybdate? So here you have, what is the color? Color is yellow. If yellow color is formed, so we can say phosphorus is present in the organic compound. Phosphorus is present. How to remember? There is 3, NH4 thrice. Here also O3. So starting with 3, ending with 3. Then here we have 4. So 3 into 4, that is 12. So NH4 thrice, PO4. 12 MOO3. Okay, so that is formed here. So that is ammonium phosphomolybdate. So first step kya hai? So we have an organic compound treated with sodium peroxide. Sodium phosphate is formed. Sodium phosphate plus nitric acid, H3PO4 plus nano3, NaNO3 is formed. Then I'm taking H3PO4, I'm treating that with ammonium molybdate. Then our final product is ammonium phosphomolybdate. So finally, ammonium phosphomolybdate is formed here. So what is the color of ammonium phosphomolybdate? That is yellow color. So yellow color precipitate is formed. It indicates the presence of phosphorus. So this is the test for our phosphorus. So for halogens we have studied. For phosphorus we have studied. For nitrogen we have studied. For sulfur we have studied. For carbon and hydrogen we have studied. So these are the detection methods. Qualitative analysis. YouTube friends, hi. Hi YouTube friends. We are also there. Okay, so these are the different tests. That is qualitative analysis. Next, what is next? Quantitative analysis of organic compound. Is that clear to you up to this point? Different reaction. So ammonium phosphomolybdate, you have to remember the color of that one. Especially in this portion, you have to remember what is the final product. What is the formula of the final product? What is the color of the final product? So that is very important. So in the last class also, we have discussed some previous year questions. Is that clear to you, JNV Karimnagar students? Then JNV Srikakulam students? Then JNV Warangal students and JNV Pune students? Is that okay for you? Qualitative analysis of organic compounds, qualitative. Okay, fine, JNV Srikakulam students. So we have detected the presence of element, right? Now we have to calculate. So what is the percentage? Percentage of the element present in the organic compound. That is known as quantitative analysis of organic compounds. We have to find the quantity of that element. So how to find that? How to find that? So we have to study about that. Quantitative analysis of compound. So we have to find, or we have to determine the mass percentage of the element present in a compound. How to find percentage? Suppose in the examination, Avanti test, you are getting 10 marks out of 100. How to find the percentage? So 10 marks obtained divided by total marks, that is 100 into 100. So we will get percentage. Similarly, how to find the percentage of the elements? So what is the mass of the element divided by total mass or mass of the organic compound into 100? So that is quantitative analysis, percentage of the element present. So for which are the elements? For which are the elements, we are going to study different tests, how to calculate. So first we will study about carbon and hydrogen. What is the percentage of carbon present? What is the percentage of hydrogen present? After that, nitrogen. So nitrogen is very important. There are two methods. There is two methods. They have different name. Okay. Then after that, we have halogens. We will find the percentage of halogens. Then we have sulfur. And last, we will study about our phosphorus. So about these different elements, we have to find the percentage of this element present in our organic compound. So that is the agenda. So let us start. Let us start with our dear carbon and hydrogen. So carbon and hydrogen, they are very close friends. Okay, like your RRR movie. Okay, Ramcharan and NTR. So how to detect carbon and hydrogen? So this thing, this experiment we have studied in the last class. So what we have done here? So here we have organic compound. Okay. Then in that carbon is present. We are treating that organic compound with copper oxide. So look at the reaction. Carbon plus copper oxide. I will get Cu plus CO2. CO2 is formed. Then hydrogen is also present in that organic compound. Organic chemistry means carbon and hydrogen. So hydrogen plus copper oxide, cupric oxide. I will get copper plus water. So CO2, carbon dioxide, H2O, water, it is formed. So why it is formed? So because of the presence of carbon and hydrogen. If there is no carbon, carbon dioxide won't be formed. If there is no hydrogen, H2O won't be formed. Right. So in this test tube, carbon dioxide gas is formed. H2O is also formed. Then here you can see anhydrous copper sulfate. Anhydrous. There is no water of crystallization. What is the color? That is white in color. Then our H2O vapors are coming. Then copper sulfate is saying H2O, come here. Then copper sulfate in the presence of water. So what will be formed? Blue vitriol. Blue color will be formed. There is water of crystallization. So I will get CuSO4 5H2O, that is blue in color. Suppose initially copper sulfate is 100 gram. Now water is also coming. What about the mass? Whether there will be increase in mass or decrease in mass? Of course, there will be increase in mass. Initially 100 gram. Maybe due to the presence of water, it becomes 200 gram. So 100, 200. Difference is 100, right? So why that 100? It is due to the presence of our water. So we can estimate the percentage or the mass of water present. Similarly, water is formed. Then second kya hai? That is CO2. Carbon dioxide is formed. Then carbon dioxide, I am passing it through calcium hydroxide. I am passing it through lime water. Then what will happen there? So can you tell me? Carbon dioxide is passed through lime water. Lime water turns dash. What is the answer? In 10th class, 8th, 9th, 10th, you have studied. So what will happen then? So what is a change? So carbon dioxide through lime water turns dash. So that is milkiness, right? So milkiness appears. So why? Calcium carbonate is formed there. If I am passing excess amount of carbon dioxide, then what will happen? So milkiness will disappear. Why? Calcium hydrogen carbonate is formed. So how can I detect the presence of carbon and hydrogen? One is with our copper sulfate. Due to the presence of H2O, color is changing. Then carbon dioxide. Why carbon dioxide? It is due to the presence of carbon. So carbon, carbon dioxide. Carbon dioxide pass through lime water turns milky. So I can say in this organic compound, there is carbon present. There is also hydrogen present. So that is how we detect the presence of these elements. So detection is done. Qualitative analysis is done. Now we have to estimate the percentage of carbon present, percentage of hydrogen present. How to find that? So let us do some numericals. Okay. So listen carefully. How to find the percentage? How to find percentage? Your marks. So marks obtained 10 marks divided by a total mass of, total marks 100 into 100, you will get percentage. Similarly, here percentage of carbon means mass of carbon divided by mass of organic compound into 100. Very simple, very simple. It is very simple. Let us do that. So I have an organic compound. Mass is given, that is m gram. M is the mass of organic compound in gram. Okay. So next step, what is next? I have carbon dioxide. Carbon dioxide formed due to the presence of carbon. So mass of carbon dioxide, I'm taking it as M2 gram. Okay. Then you know molar mass. Molar mass of, you have to tell me the answer in the chat box. Molar mass of CO2. What is that? Molar mass of, or molecular mass of CO2. So what is the value for that one? Molar mass of CO2. What is that value? CO2, 12, carbon 12, oxygen 16, 16 into 2 plus 12. So what is the mass, molecular mass of CO2? So what is the value? You have to tell me the value. So what is the value? So you have to tell me in the chat box. In the chat box. Yeah, 44 JNV Srigakulam students, correct. I think some problems with my pen tab. That is why so many lines are being drawn. It's not done intentionally. So it is happening. So I know mass or molecular mass of carbon dioxide, that is 44 gram. So I'm taking in 44 gram of CO2. So what is the mass of carbon present? Only one carbon present. So in 44 gram of CO2, what is the mass of carbon present? Only one carbon. So what is the mass of carbon present in 44 gram of CO2? You have to tell me. JNV Srigakulam students, Karimnagar students, all of you can tell me the correct answer. So what is the value? What is the value? So what is the mass of carbon? Yeah, correct. JNV Srigakulam students, that is correct. So it is 12 gram of carbon. 12 gram of carbon is present. 44 gram, in 44 gram, 12 gram. So what about in 1 gram of CO2, what is the mass of carbon present? That is 12 divided by 44 gram of carbon. Okay, then, so look at here. What is the mass of carbon dioxide given in the question? That is M2 gram. In 1 gram, 12 upon 44 gram of carbon is present. So what about the mass of carbon in M2 gram of carbon dioxide? How to find? So in M2 gram of CO2. So what is the mass of carbon present? That is 12 divided by 44 into M2 gram of carbon. So we got mass of carbon present. We have to find the percentage of carbon. How to find? Mass of carbon divided by mass of organic compound into 100. So how to find that one? Percentage of carbon, like your marks, percentage of carbon. So first I can write the mass of our carbon, that is 12 into M2 divided by 44. Okay, then in the denominator, there is mass of organic compound, that is M. Then for percentage into 100. So how to find the percentage of carbon in the organic compound? 12 into M2 into 100, then divided by 44 into M. So that is how you can find. Is that clear to you? This one, percentage of carbon. Is that clear to you? Molecular mass of CO2, 44. In 44 gram of CO2, 12 gram of carbon. In 1 gram of CO2, 12 divided by 44. In M2 gram of carbon dioxide, 12 divided by 44 into M2. Is that clear to you? Yes or no? Then percentage of carbon, mass of carbon divided by mass of organic compound into 100. That is how we can find the percentage of carbon. Yes or no? Is that clear to you? How to find the percentage of carbon in the organic compound? Yes or no? If it is clear, we will do it. One more example. How to find the percentage of hydrogen? So carbon dioxide. Due to the presence of hydrogen, water is formed. So based on water, we can find the percentage of hydrogen. Okay. So let us check that one. So I have an organic compound. Okay, JNV Srigakulam students. I have an organic compound. Its mass is m gram. Okay. Then we have water, H2O. Mass of water, I'm assuming that m1 gram is present. Then you have to tell me the answer. What is a molecular mass of water? Fast. Molecular mass of water. What is that molecular mass of water? So what is the value? You have to tell me. Yeah, JNV Srigakulam students, correct. 18 gram. So 18 gram of water contains how much amount of hydrogen? There are two hydrogen, right? So two hydrogen means 18 gram of water contains dash gram of hydrogen. So what is the value, JNV Sri? Yeah, two, correct. 2 gram of hydrogen, 2 gram of hydrogen. Okay. Then unitary method. Then if 1 gram of H2O is present, 1 gram of H2O is present, what is the amount of hydrogen? That is 2 divided by 18 gram of hydrogen. 2 divided by 18 gram of hydrogen. Here we have M1 gram, right? So M1 gram of water is present. Then tell me, in M1 gram of water, what is the mass of hydrogen percent? So I can write 2 divided by 18 into M1 gram of hydrogen. Now we have to find the percentage of hydrogen. We know the mass of hydrogen divided by mass of organic compound, then percentage into 100. How to find that one? So percentage of hydrogen, that is equal to 2 into M1 divided by 18. Then in the denominator, there is mass of organic compound, then percentage into 100. So we have found percentage of carbon, percentage of hydrogen. Then qualitative analysis of carbon and hydrogen, we have studied in the presence of copper sulfate, then lime water turns milky. So that is qualitative. This is quantitative. Why quantitative? We found the percentage of carbon. We found the percentage of hydrogen present in the organic compound. Is that clear to you? First one, quantitative analysis. Is that clear to you? You two friends, you can tell me in the live chat section. Okay, fine. So all this quantitative analysis, you can do like this. It is very simple. You can follow this method, but during the final exam, you have to remember the equation. So you have to take a piece of paper later after the class. Then you have to write percentage of hydrogen. What is the equation? 2 into M1 into 100 divided by 18 into M. So how to calculate percentage of carbon? You have to write it in a single sheet. Then it is done. Then during exam time, you have to just revise that. Okay. Then carbon, hydrogen, that is done. Second, we have to go for nitrogen. Estimation of nitrogen, we have to find. There are two methods for the quantitative, that is percentage of nitrogen. There are two methods. First one is known as Dumas method. Second one is known as Kjeldahl's method. During my time, during my 11th, first of all, I opened the NCERT textbook. That time I saw the name. I thought Khadija, not Kjeldahl's method. First we read Khadija. Okay, first time. Then after that we did it correctly. So nitrogen, there are two methods. One is Dumas method. Second one is Kjeldahl's method. So based on this method, numericals, you have to remember the equation. Then you can simply do the numericals. So let us start with our Dumas method. How to estimate or how to find the percentage of nitrogen in an organic compound. So we have to find that one. How to find that one? There are certain reactions. Then we will get some product. Last is carbon dioxide and H2O. They were the products. Based on carbon dioxide, we found the percentage of carbon. Based on water, we found the percentage of hydrogen, carbon and hydrogen. Then, okay. Then here, what is happening here? So we have an organic compound. Then organic compound plus copper oxide, CuO. Okay, reactions happening, CuO plus organic compound. Then so many items are formed. So this is a reaction. No need to by heart the reaction. Okay. So here we have an organic compound. Here we have an organic compound containing nitrogen. Then reaction with CuO. Then carbon dioxide is formed. Water is formed. Nitrogen is formed. So we want to find percentage of nitrogen. Here nitrogen gas is formed. So we can find the percentage of nitrogen from our nitrogen gas. So these are the different products formed. One is carbon dioxide, then water, then nitrogen. So we want to study about our nitrogen gas. Okay. So in this, there's different gases. You can see a jar, right? So in this nitrogen gas is present. Then water is also present. Carbon dioxide, it is also present. So you can see nitrogen. So using this setup, we can find the volume of nitrogen. So volume of nitrogen we can find. Then pressure also we can find. So you using this apparatus, we can find the volume of nitrogen and pressure. Okay. So based on nitrogen, we are going to find. So you have to listen carefully. It is very important. It is somewhat difficult also. Okay. So nitrogen, water, CO2. So nitrogen is the. If I calculate the pressure, I will get pressure due to moist gas. Moist gas means water is present. So that is why moist gas. So what about the real pressure of nitrogen? So take the pressure of moist gas minus aqueous tension or pressure of water. Then I will get the real pressure of nitrogen. So let us calculate the percentage. So this is the equation. So this is the equation X, Y, Z. So this is 2 X. Here we have X. Then X CO2 is formed. Here we have Y, suppose 4. Then what about H2O form? 4 by 2. So this is a balanced equation. How to write the equation? Okay. So what we have to do here? Again, same, your marks. So what is the marks obtained? Divided by total marks. That is Avanti test. You are scoring 10 marks out of 100. Okay. So not you. Okay. Other students. 10 divided by 100 into 100. You will get the percentage, right? So here also, like total mass of organic compound, that is in the denominator m gram. Then we have to find the mass of nitrogen, then into 100. So we will get percentage, right? So we have to find the mass of nitrogen form. Actually here nitrogen gas is formed. So we can say volume of nitrogen. Using that apparatus, we can find the volume of nitrogen. So we got V1 ml, that is the volume of nitrogen calculated using this apparatus, found using this apparatus. Okay. Then what about the temperature? So this volume, nitrogen has this volume at room temperature. Experiment is done at room temperature. That is why temperature is T1. That is our room temperature. Okay. Then pressure also, we know pressure also. We will study about the pressure. Then here in first chapter, mole concept, you have studied something. So all those things we have to recollect. Okay. So in states of matter, you have studied something. So that data also we need. So we have to find the volume. So we have to find the volume of, we have to find volume of N2 at STP, volume of nitrogen at STP. Okay. So that is, I'm writing it as Vm. Then after that, we have to calculate the mass of nitrogen. Then volume of N2 at STP. What about the temperature at STP means temperature, I can write it as 273 Kelvin. What about the pressure? Pressure, I can write it as 1 atm or 760 mm of mercury. So that is the pressure at STP. So we have to find the volume of N2 at STP. Temperature at STP 273 Kelvin. Pressure 1 atm or 760 mm of HT. I have V1. I have P1. I have T1. I have to find V. Then T2, P2, that is also given. How to find? So that is our states of matter chapter. Chapter our states of matter. That is P1 V1 divided by T1 is equal to P2, then V. What is V? Volume of N2 at STP divided by T2. So what's the value of T2? That is 273 Kelvin. That is STP. Then P2. What's the value of P2? That is 760 mm of HT. Then what about P1? P1, that is found using the apparatus, that setup. Then V1, volume of nitrogen collected in ml, that is also found using this experiment. What about T1? T1 is a temperature, room temperature. So first of all, what we have to do? Mass of organic compound, that we know. Using the experiment, we can find the volume of nitrogen collected, V1 ml. Experiment is done at room temperature. So T1 is a room temperature. So in the question, they will give the values. Then we have to calculate the volume of nitrogen at STP. So that I'm writing it as V capital V. What about STP? Standard temperature and pressure. So temperature, that is given, already given, standard temperature and pressure, 273 Kelvin. What about the standard pressure? That is 1 atm, or we can call it as 760 mm of Hg. Then how to find? So LHS, some terms, RHS, some terms, P1, V1, T1, that is found. P2, T2, you know, you have to calculate the value of V. Okay, so that is the thing you have to do. Volume of nitrogen at STP, that is equal to P1 V1. This V1 using the experiment we can find. So P1 also we can find using the experiment. This is STP. This is pressure 760 mm of Hg. Then T1, that is a room temperature. So in the question they will give that. What is P1? P1, that is pressure of moist gas. So moisture. So pressure of moist gas. Then there is pressure due to water. That is aqueous tension, moist gas, water vapors. So aqueous tension is there. So what about P1? Take the pressure of moist gas minus the tension or the pressure by your water, aqueous tension. So if I do that, I will get P1. That is our pressure of the gas. So pressure of moist gas, it is found using the experiment. Minus aqueous tension, I will get P1. Now what we have to do? We have to just substitute the values. Then you will get the answer. Now I got volume of nitrogen at STP. Okay, so volume of nitrogen at STP I got. Now I have to find the percentage of nitrogen. How to find? I need the mass of nitrogen present divided by mass of organic compound. Mass of organic compound, that I know. What is that here? Then how to find mass of nitrogen? Okay, so volume we have. From volume, I have to convert it into weight. How to do that? So we have STP condition. So I can say at STP, 1 mole of N2 occupies dash volume, that is 22.4 liter, or I can write 22400 ml. Okay, so 1 mole means what is the weight? 28 gram. That is a weight. Okay, chat box. Okay, due to the water, aqueous tension, due to the water. So pressure due to water, that is aqueous tension. Okay, so aqueous tension, there is moist gas. So due to water vapors, then minus aqueous tension, you will get the real pressure of our nitrogen gas, real pressure. Okay, then after that, we got the volume of nitrogen at STP. Substitute the values, you will get that. Then volume into weight. Okay, so 1 mole of N2 at STP. That is 22.4 liter volume. It occupies 22.4 liter. Or I can say 22400 ml. Right. So 22400 ml N2 at STP weighs 28 gram. 1 mole N2. That is 28 gram. Then you have to tell me, what about 1 ml? So 1 ml N2 at STP weighs 28 divided by 22400 gram. Okay, then what about VML? VML N2 weighs how much? 28 divided by 22400 gram into this capital V, that is a volume. So we got the gram, answer in gram. So what is that? That is the weight of our nitrogen. So 28 divided by 22,400 into V, that is a weight or mass of our nitrogen. So we got the mass. How to find the percentage? How to find the percentage? So percentage of nitrogen, that is equal to mass of nitrogen, that is 28 into V divided by 22,400. Then in denominator, there is M. What is small m? That is a mass of organic compound. Then into percentage, that is into 100. So we got the answer. So this is our Dumas method. So in Dumas method, so what is happening in our Dumas method? Yeah, Binod, good afternoon. So what is happening in our Dumas method? So go through that once more. Dumas method. So copper oxide plus organic compound. Then different products are formed: carbon dioxide, water, nitrogen, etc. Then nitrogen gas is present. Then water is also present. So we can calculate the pressure of nitrogen. Then other pressure you can calculate. Volume you can calculate. Then again equation. So P1 V1 divided by T1 is equal to P2 V divided by T2. So we are converting it into volume of nitrogen at STP, that is VML. Then at STP, temperature 273, pressure 180 or 760 mm of Hg. Then calculate the value of V, capital V. So we got the value of volume of nitrogen. Okay. Then based on your some basic concept, right? So 1 mole, it occupies 22.4 liter of volume at STP. Then VML, what is the weight occupied by VML of nitrogen? That is 28 divided by 22,400 into volume, right? Then final equation, you know, percentage of nitrogen. That is 28 divided by 22,400. Then there is V in the denominator, then M in the, numerator, denominator into 100. Is that clear to you? This thing, this Dumas method, you have to go through the NCERT once more. It is very important. At least you should know the final equation. This final equation, percentage of nitrogen. Okay. So first one, it was easy. This one is somewhat difficult, right? So I have explained that. You have to read it once more. Then it will be perfect for you. So is that okay for your estimation of nitrogen by Dumas method? So in the examination, you have to remember the final equation only. No need to derive all these things. Okay. Karimnagar students, this one you have to read it once more. Then only it will be clear. Then there are some questions also based on this Dumas method. They will give volume or they will give mass. You have to substitute the values. Okay, then I hope this is clear to you. This Dumas method. Okay, so that is about our Dumas method. Then there is one more method, that is Kjeldahl's method for the estimation of nitrogen. So I'm not explaining that in detail. Okay, it will get too much confused. So we will study about the important points. So what is happening here in the first step? So that's known as digestion. Your biology, digestion and absorption chapter, right? So here what is happening? I have a Kjeldahl's plus. In that I have organic compound. Then concentrated H2SO4 and copper sulfate. Then reactions happening, organic compound plus H2SO4, then H4, NH4 twice SO4. Ammonium sulfate is formed here. So in first step, ammonium sulfate is formed. So this is known as digestion. So Kjeldahl's plus, in that organic compound plus H2SO4 reaction happens, ammonium sulfate is formed. That is digestion. So Kjeldahl's plus I'm taking, and second is distillation. So there are some content in the Kjeldahl's plus. I'm taking that plus NaOH. I'm adding some NaOH. Then what is happening here? So ammonium sulfate in the presence of sodium hydroxide, basic medium, right? So what are the materials from? What are the products from? Na2SO4 and ammonia plus water. So I am taking this ammonia. Then what I am doing? Ammonia plus again H2SO4. Then I am getting ammonium sulfate again. This is more pure form. Ammonium sulfate in a pure form. So ammonium sulfate is formed. So based on ammonium sulfate, we can estimate the percentage of nitrogen. So you have to find what is digestion. In the first step, what is happening? So first step, what is happening in the first step? That is our digestion. So this is the first step, organic compound plus H2SO4, ammonium sulfate is formed. Then I am taking the content of the Kjeldahl's plus, then I am adding NaOH. So in that reaction, Na2SO4 and ammonia is formed, plus water. Then I am taking this ammonia, then reaction between ammonia and H2SO4, then again ammonium sulfate in pure form is formed. So we can estimate the percentage of nitrogen based on ammonium sulfate. Okay, so that is the point. So there are so many derivations. So I'm giving you the final product. So you have to study the final product, then you can solve any questions. So we will discuss the important points related to the Kjeldahl's method. So after all the derivation, so here in your screen, you have the final equation. So how to find the percentage of nitrogen in an organic compound using Kjeldahl's method? So take it 1.4 into N. What is N? What is N? So N is our normality. N is our normality. Then if molarity is given, how to find normality? So normality is equal to molarity into N factor or valency factor. So can you tell me for H2SO4, what is the N factor for H2SO4? How many H plus it can release? That is our N factor. So can you tell me the answer for H2SO4? What is the N factor, valency factor? In the case of HCl, what is the N factor? In the case of HCl, what is the N factor? So H2SO4, 2 hydrogen. It can release 2 hydrogen. Yeah, JNV Srikakulam students, correct. So here it is 2. What about HCl? So in the case of HCl, it is 1. So how to find normality if molarity is given? So molarity into N factor or valence factor. So you will get normality. What about V? That is our volume. What about the small m? That is a mass of organic compound. So 1.4 into n, normality, into volume of nitrogen divided by mass of organic compound. So we have to listen. No need to multiply this with 100. Already derivation is done. So in that derivation, we have already added 100. Okay. So no need to multiply this with 100. Already you will get the answer in percentage. So percentage of nitrogen in organic compound using Kjeldahl's method, the equation is 1.4 into n into v into, then kya hai? In denominator the ratio. So that is our Kjeldahl's method. Kjeldahl's method. Is that okay for you? Dumas method and Kjeldahl's method. Dumas method volume. Okay, we have found the volume of nitrogen at STP. So that is based on concept from mole concept chapter and states of matter chapter. Okay, JNV Srigagalam students, fine. So today itself, you have to take a piece of paper, full paper, then you have to write the equation. Percentage of carbon, how to find. Percentage of hydrogen, how to find. Percentage of nitrogen using Kjeldahl's method. Percentage of nitrogen using Dumas method. Okay. Then some more important points. So in Kjeldahl's method, what is the final product? Ammonium sulfate. So Kjeldahl's method is not applicable to compounds containing nitrogen. So which are those nitrogen compounds? One is nitro compounds. Here you have nitromethane. Second, you have SO compounds. SO means N double bond N. Third, you have nitrogen in a ring. Okay. Why they are now not applicable? Why Kjeldahl's method is not applicable for them? In Kjeldahl's method, estimation is based on ammonium sulfate. But these three, nitro compounds, SO compounds, if nitrogen is present in the ring, they cannot form ammonium sulfate. So that is a reason for that. So without forming ammonium sulfate, how can we estimate the percentage of nitrogen in the organic compound? So these are the limitation or exception, you can say. Nitro compounds, SO compounds, and the pyridine. Okay, pyridine means nitrogen in the cyclic ring. So that is our Kjeldahl's method. Okay, so our time is almost over. So we can stop it here. So before that, I will give you one question for you. So what is the correct answer for this one? Very simple question, but this is a previous year question. Previous year question. Kjeldahl's method is used in the estimation of dash. Yeah, JNV Srigagalam students, correct. What about other JNVs? JNV Warangal, that is correct. Then other JNVs, JNV Pune, JNV Karimnagar. So very simple question. This is a previous year question. Then JNV Vishakhapatnam, JNV Warangal, JNV Agola, Karimnagar. So very simple question for you. Okay. Yeah, fine. So that is a question for you and one homework question. So here there is a one homework question for you. So I will give you some hint. So this is based on which method? Yeah, Dumas method. So volume is very important. So what is the final equation? Percentage of nitrogen 28 into V into 100 divided by 22,400 into M. So what is M? What is M? The mass of organic compound. So Dumas method of estimation nitrogen 0.35. That is a mass of our organic compound. Then we have to find volume. How to find volume? That is P1 V1 divided by T2. That is equal to P2. Then we have V divided by T2. So P2, you know, the value is 760. This one value is 273. Then here temperature that is given. That is 300 Kelvin. 300 Kelvin. That is a temperature. Then volume is given. That is 55. 55. That is a volume given. Then what about the pressure? That is pressure of the moist gas minus aqueous tension. So what is the pressure of the moist gas? That is 715. 715 minus 15. So we will get P1. 715 is the pressure of the moist gas minus aqueous tension. So first you have to find the value of V. Then you can find percentage of nitrogen 28 into V. Volume into 100 divided by 22,400 into M. M is a mass of organic compound that is given as 0.35 gram. So this is a homework question for you. You have to do it. Okay. So here we will end it. We will discuss the other things in the next class. So this is a very important class. So there are different equations. You have to study that. What are the methods? what are the reaction, so what is the final product form, so what is the color of that final product. So you have to study all these things. If it is fine, we can end it here. Thank you, students, for attending the class. So you have to do it as a homework question. It's a very important question. This is a previous year question. Percentage of nitrogen using Dumas method. Yeah, JNV Srigakulam students, check that once more. Okay. Check the option once more. Some small correction. You have to check the answer once more. Some calculation mistake, maybe. The options are very close. That is why. Okay, then students, you can leave the meeting. Bye-bye. See you in the next class. We have studied so many things. You have to make a note of that. So Dumas method. First find the volume P1 V1 divided by T2. That's equal to P2 V divided by T2. Then STP, pressure 760, temperature 273. Then in this case, experimental setup, we have found the volume 55 ml of nitrogen, pressure of the gas, pressure of moist gas minus aqueous tension. The temperature is given as 300 Kelvin. Bye, students. We will see you in the next class. So bye-bye, all of you. It's a very important portion. You have to study that. You have to make a note of that. Okay, then. See you in the next class. Bye, JNV Srigakulam students. Okay, I'm stopping it here. JNV Mahi, JNV Varda, JNV Akola, JNV Visakhapatnam. Great. All our regular JNVs are present here. So I'm ending the meeting.